Hi, welcome to ClickMyProject.com. This video will lead us to the demo of cost-effective, authentic and anonymous data sharing with forward security. Data sharing has never been easier with the advances of cloud computing, and an accurate analysis on the shared data provides an array of benefits to both the society and the individuals. Data sharing with a large number of participants must take into account several issues, including efficiency, data integrity, and the privacy of data owner. Ring signature is a promising candidate to construct an anonymous and authentic data sharing system. It allows a data owner to anonymously authenticate his data, which can be put into the cloud for storage or analysis purpose. Yet the costly certificate verification in the traditional public key infrastructure setting becomes a bottleneck for this solution to be scalable. Identity-based ring signature, which eliminates the process of certificate verification, can be used instead. In this paper, we further enhance the security of ID-based ring signature by providing forward security. If a secret key of any user has been compromised, all previous generated signatures that include this user still remain valid. This property is especially important to any large-scale data sharing system, as it is impossible to ask all data owners to re-authenticate their data even if a secret key of single user has been compromised. We provide a concrete and efficient instantiation of our scheme, prove its security, and provide an implementation to show its practicality. First of all, create the rings. These rings contains the number of nodes. Now we create two rings, that is ring 1 and ring 2. From ring 1 we have to select the node as source node, and then from ring 2 we have to select a node as destination node. Between these nodes the data is transferred, and then the source node have to select a data. This data must be encrypted for the security purpose. For that the key generation is used. Using that key the data is encrypted, and then the MAC is also generated for the data. MAC means message authentication code. Message authentication code is used to check the integrity of the data, and then the data is transferred to intermediates. There are two intermediates are selected. First of all, select the intermediate 1 and then intermediate 2. Then the data is transferred from the source to admin. From admin the data is transferred to intermediate 1. From intermediate 1 the data is transferred to intermediate 2, and then from intermediate 2 the data is transferred to destination. Destination, that is the receiver, receives the data and then checks the integrity of the data and also decrypts the data. Using the key the data is decrypted because the data is in the encrypted form. So the data is decrypted, and then the message authentication code is executed by the destination. After executing the message authentication code, the destination got the code, that is the MAC. This MAC is compared with the existing MAC that is generated by the source node. If both the MACs are equal means then the integrity of the data is confirmed. Otherwise the integrity of the data is not confirmed. This means the data may be modified in some other places. Let us see the demo of the project. First of all, run homepage.java and then press enter. Now enter the number of nodes, and then here also enter the number of nodes. Now press create ring 1. Now the ring 1 contains 10 nodes, and then click create ring 2. Now the ring 2 contains 15 nodes. From ring 1 the source is selected. Now the selected source is node 2, and then from ring 2 the destination is selected. Now the selected destination is node 4. Then click next. Then press select. Now check the file name. Here the file name is displayed, and then click location. The location of the selected file is also displayed, and then click format. The format of the selected file is displayed, and then press size. The size of the selected file is also displayed here. Now click the view button. Now the data present in the selected file is displayed here, and then press next. Now there are two intermediates are need to be selected. From these two intermediates, the data is transferred to destination from source. For that, first of all select intermediate 1. Now the intermediate 1 is node 5, and then select the intermediate 2, that is node 10, and then click next. Now enter the secret key. Now press get key. The key is stored in the buffer, and then press encrypt. Now the data is, that is the selected data is encrypted by using the secret key. Click OK, and then press original data. Now the original data is displayed here, and then click encrypted data. The encrypted data is displayed here. Press the get button. In that the message authentication code is generated for the selected data, and then press transfer to intermediate 1. Now the data is transferred to intermediate 1, that is called as node 5. Now press view data. The data received by the node 5 is displayed here, and then click next. From here the data is transferred to admin, so that the admin have to view the data and then enter the username, and then enter the password. Then press send. Now the data is sent to admin, and then click next. Now select the file name for download. Now click download and press view. Now the file is downloaded from the admin, and then press next. This file is now received by the intermediate 2, and then click next. Now the destination have to enter the key. Now press get key, and then click decrypt. Now the data is decrypted. Then press encrypted data. Here the encrypted data is displayed here, and then press decrypt. It is the decrypted data. This data is decrypted by using the key entered here. Then press verify. Now the message authentication code is also generated here. It is compared with the existing message authentication code, and then displayed the result that the data is not modified.